Altos Hornos de Mexico, AMSA, is a fully integrated steel company which produces steel through processes ranging from the mining of iron and coal from its own mines to the completion of finished products. At the beginning of the steelworking process, the mineral ore is treated by pelletization and sinterization, while the coal is processed by coking. Coming from Hercules in the Coahuilan Desert, iron reaches the pelletizing plant as a sludge through a duct 14 inches in diameter and 180 miles long. This sludge is subjected to filtration. The water is recovered and the dry ore is sent to pelletizer discs to be mixed with binding agents to form small balls called pellets. At 1,300 degrees Celsius, the pellets are heat hardened before being sent to blast furnaces. Meanwhile, the coking plants receive metallurgical coal by rail from the Carboniferous region of Coahuila and treat it in vertical ovens lined with refractory brick. Through 18 hours of baking, the coal is transformed to coke, the basic fuel for the blast furnaces that produce pig iron or first fusion iron. During this process, various byproducts are obtained, among them coke oven gas, a fuel used in later stages of the steelmaking process. Another raw material for the blast furnaces is sinter, a porous mass composed of iron ore, flakes, and powder produced by the steelmaking process itself. Blending with lime, coke fines, and dolomite produces a mix that is hardened in the continuous chain oven of the sinter plant. Processed iron and coal, the basic raw materials for producing pig iron, are sent to blast furnaces consisting primarily of a large cylindrical structure over 160 feet high whose interior is lined with refractory brick. In the blast furnace, the iron oxides contained in the pellets and sinter, which are stored in a hopper's facility, along with limestone, dolomite, and coke, are reduced and converted to pig iron. Mixed in the proper amounts, these raw materials produce layers of various thicknesses when they are deposited in the blast furnaces through the charging system located on the top. Hot air is introduced under pressure into the bottom of the furnace, blasting the coke and smelting the iron ore in an environment of up to 1,650 degrees Celsius. In the lower part of the furnace, a graphite hearth or crucible receives the molten metal, which then is drained through tap holes and troughs and emptied into 200 metric ton capacity torpedo cars. In order to eliminate sulfur content, reagents such as calcium carbide and magnesium are applied to the pig iron in the desulfurization plant. The slag generated during the smelting is deposited in a slag pit to be cooled with water. It is later stored or sold as a byproduct. For the conversion of pig iron to steel, AMSA uses the oxygen-based technique of steelmaking called BOF, Basic Oxygen Furnace, as well as an electric arc furnace. BOF steelmaking begins by loading scrap metal into the converters, pear-shaped refractory-lined furnaces with capacities of up to 150 metric tons lined internally with refractory brick. When the proper amount of scrap metal has been loaded into the converter, molten pig iron is added by means of large ladles operated by traveling cranes. For refining, oxygen, argon, and nitrogen are injected into the mix under pressure through tubes known as lances connected at the top and bottom of the converter. After a period averaging 45 minutes, liquid steel is obtained. The steel is poured into large ladles and ferroalloys are added in order to adjust its chemical makeup to match the requirements of the material ordered by our clients. Production of liquid steel by means of the electric arc furnace is conducted by beginning with a mixture of scrap metal, iron briquettes, or liquid pig iron at a rate of 150 metric tons per casting. Scrap and briquettes are loaded by using baskets, while the pig iron is transported by a gutter to the furnace, where 3 graphite electrodes apply 140 megavolts of electric energy to melt the load and produce steel, which is emptied into special ladles. In order to produce specific properties, the liquid steel from both systems goes to the secondary treatment station, secondary metallurgy, ladle metallurgy, or chemical reheating. Likewise, liquid steel can be processed in the dual degassing station to reduce the content of hydrogen and carbon for applications with higher requirements. With the treatment completed, liquid steel is transformed into slab on equipment called continuous casting machines. In this process, as it passes through a series of rollers with a cooling system, it begins to solidify until it becomes a slab which is cut with oxygas to the required dimensions. The steel slabs are produced in different thicknesses, widths, lengths, and weights, and each piece is labeled for later processing by hot rolling. The hot rolling department, considered the backbone of AHMSA operations, has a hot strip line which produces steel strip coils and two plate lines to produce steel plates in sheets or coils. On both lines, the slab is reheated to 1,330 degrees Celsius. Plate line 1 has two reversing mills that in a series of passes generate wide plate in the required thickness and width. On plate line 2, the 8-inch slab is laminated in a reversible Stecco mill, and the steel strip is temporarily stored in closed box furnaces to maintain temperatures above 1,000 degrees Celsius. Subsequently, an edger mill reduces the width of the strip to produce plate in sheet or coil. If required, the plate goes to the normalizing line, where through thermal treatment a uniform granular structure and greater hardness of the steel is obtained. AHMSA is the only manufacturer in Mexico that produces steel plate, which is used for making farming and mining machinery, oil industry machinery, as well as heavy automotive and railway products. On the hot strip line, the slab is processed for the production of hot-rolled coil. First, the slab is reduced in the universal reversing mill to a thickness of 2 inches, and then on the M stand it is further reduced to 1 inch. The final thickness required by the customer is achieved on the 6-standing roll mill train. At the end of the hot strip line, there is a cooling system and a coiler. Hot-rolled coil, also known as full hard coil, is shipped directly to the customer or sent to other processes in the AHMSA cold rolling departments. Through cold rolling, the thickness of the sheet is reduced, while at the same time modifying and enhancing its physical properties. The process begins with pickling in order to eliminate oxides through the use of a hydrochloric acid-based solution. Then the strip is cooled to room temperature in various mills in order to gradually reduce its thickness and achieve the desired specifications. In order to soften the material, the coil is annealed in a continuous heating oven at temperatures of up to 750 degrees Celsius. The steel strip then goes to the tempering mills, which give it a greater surface quality and the specified hardness required for the various applications. In addition, AHMSA has skin pass and tension leveling lines which improve the surface quality of the hot-rolled and cold-rolled coil respectively. In these units, a greater thickness uniformity is achieved, which is an essential requirement for manufacturers in the automotive industry, home appliances, and electrical steel. Furthermore, AHMSA produces tin plate and tin-free steel, which are steels produced primarily for manufacturing of metal containers. In both cases, the cold-rolled coil is subjected to an electrolyte bath with tin and chrome, respectively. In addition to the hot rolling and cold rolling lines, there is a department of structural shapes. AHMSA is the primary domestic manufacturer of structural steel for the construction industry. Production begins with the cutting of the steel slab into square pieces called blooms. Reheated in an oven at over 1,250 degrees Celsius, the blooms go through various rolling mill trains to produce structural shapes such as W shapes, C shapes, and angled L shapes. Built on advanced information technology systems, the AHMSA productive chain requires support services such as industrial gases, electric power, water, transportation, and maintenance shops. Altos Hornos de Mexico operates its own power plants which use steam and internal combustion engines to produce electrical power and blast air for blowing into the blast furnaces. There are also units for the production of oxygen, argon, and nitrogen, as well as water treatment plants for raw sewage, industrial, and sanitary water. From the iron and coal mines all the way to the delivery of steel to the customer, the Altos Hornos de Mexico productive chain is backed by national and international standards.